section's on 10.1 parametric functions. So we're going to continue from what we did yesterday, but in this case, we're going to actually graph it, okay? So I'm going to teach you how to graph it also on using the graphing calculator portion of it. So on the graphing calculator, notice that this equation right here, we have t's and y's. So we're going to go under the mode section right there, and under mode, you're going to press this button right there. And notice in previous problems, we've always done it the function right there. When we did function, we get y equals, and you get something like x variable. There's another thing called the parametric right here. So we're going to go with the parametric. So using your arrow keys, move over to the parametric, and then make sure you always press enter to store that in the memory of the calculator. Okay? So then I'm going to exit out of this, quit out of it. And so now parametric, when we go under y equals this time, under y equals right there, notice what happens. You have an x and a y, which we need because we're going to enter in those equations. Okay? Also, I want to point out that right here, before, when we did functions, it was always x right there. But when we went to parametric, what's going to happen is it's automatically become t's because that's what we need for this part of the equation right there, the t plus 1 and 2t squared plus t, okay? So let's enter that in the calculator right there. So the first one is going to be t plus 1, right? And then we're going to drop down the arrow key to go to the y, and you're going to go 2t squared. The square is the same, nothing has changed, and then plus t, okay? Now, let's go under Windows, and we're going to play with the window size first because I want to introduce that as well because that's going to be different. Now, on the Windows, notice what happens. You're going to be introduced to these things called the t's right there, okay? Normally, on the calculator or the problem, they're going to tell you approximately what the t's are because there's a t right there. So you know it's going to be from -3 to +3. So you're going to play with that size right there as -3 and +3. The t step size is going to be how small it is going to draw each of the pixel size from -3 to 3. Now be careful about this because the bigger this number is, the more jaggedy the picture is, and we'll play around with that as well. But also you don't want it too small because if you get it too small, the picture will draw at a slower pace, so you almost will be in a stuck mode sometimes. So you just have to be careful of that, okay? Now, we still have the X max and X min, and also the Y max and Y min. Now, this right here, unfortunately, they do not tell you, like we've done before. So you're just going to have to play around with these guys right here just to see what it looks like, all right? So I think we'll keep it at the 5s. That looks pretty good. So let's graph this out. Okay, so that's the graph. It looks like a regular parabola, and you're probably thinking, no big deal, okay? So that's what it is in this case. So we're going to graph this out. So part A will be sketching that graph. So I'm just going to sketch the parabola, something like this. And there, okay? Now, part B, pay attention to part B. The part B is asking you to find or put little arrows to the direction that it goes to. All right, so you probably didn't even pay attention to that. You just saw that graph out and you were hoping that it would graph out something spectacular, but it didn't. It was just a parabola. So let me go back to that y equals. And usually if you didn't catch it the first time, I would just go back and press like that 1 again, and then it'll erase the graph and then start the graph again, okay? So when you go graph right there, pay attention to the direction that it's going, okay? Are you ready? Okay, here it goes. So here we are. That was the direction. It started up here and then went down and around up here, okay? That's important because you're going to have to put arrowheads. So I would say about 3 arrowheads. I would say somewhere where it starts. So this is the direction that's going. So somewhere around here. I would put probably one in the middle just to remind myself it's going this direction, and towards the end and saying something like, this is it right there. That was the direction. So in this case, be careful. We're not putting arrowheads up here and up here like we normally do on a function. On the parametric, we're showing the direction that it's flowing, okay? So that's part B. Now, part C is going to ask us to find the lowest point right there. Okay, so now using the calculus knowledge that we know from even last year and also what we did yesterday, we could find a max or min, right, by taking the first derivative. So if I take the max or min of this equation right here, I will definitely find is the minimum down here on the first derivative because I don't have a max, Okay, so let's do that. So on part C, let's set this up as a dy over dx. So dy equation is what we just did from yesterday. So we're going to copy the y equation, which was 2t squared plus t. So here we have is 2t squared plus t. And then the x equation was t plus 1. So we have is t plus 1. Okay? So now we're going to go ahead and take the first derivative of this, just like how we did yesterday. So that recalls is L'Hopital's, right? So L'Hopital says then I have is 4t plus 1 all over 1. Okay? So that's it. That's the first derivative. Now, going back to what we did in calculus AB, to find max and min, we take the first derivative and we set it equal to 0. So we set it equal to 0 and we're solving for t. So when we solve for t, the 1's gone right there. So I just basically have a 0 is equal to 4t plus 1. I bring the 1 over on the other side, becomes negative 1 equals 4t, right? And then t is equal to negative 1/4. Okay, so I'm saying that at t equals negative 1/4, it's either a max or min. Well, let's check this out right here. So here, when we graph this out, right there, the difference on this one is if I press trace now this time, so what happens is you're going to get a t, you're also going to get x, and you're also going to get a y, okay, which was not there before when we did function. So I said that t is equal to negative 1/4 is the lowest point or the max or min. So under this part right here, if I just go ahead and press in t, well, actually I don't even press in t. I just press in negative, right, because that's going to start the t up right there. So 1 divided by 4, right, press enter, and it's going to trace to this point, which is the lowest point. So yes, it proves that this is the lowest point right there. Yay. Okay, so that's the way to prove this right here. So using yesterday's and also calculus AB knowledge, we're going to do that. All right, now let's try example 2. So now example 2, doing the same thing. We have x equals sine t, y equals cosine t, and it says from 0 to pi, and we're looking for the rightmost point. Okay, so let's graph this out just to make sure I know what that graph looks like. So I go under y equals, I'm going to delete those things, clear it out, and then we put in sine for the x, so sine t, and close my parentheses, and then I put in cosine t, close my parentheses, and I'm done, okay? So now I'm ready to graph it. So again, I want to go under Windows right there, and then adjust your window size, because in the Windows, it says from t is from 0 to pi. So I want to change that from t from 0 to pi, which is then pi right there, okay? Let's keep it 0.5 for now, and then I'm going to keep it to this just to see what it looks like, because I don't know what it looks like. So we'll see. So let's graph this out now. So if I graph it out, it's going to give me something like this. Okay, that's enough. Let's make it smaller just to see it zoomed in more. So here on the, let's see, what is that? The y, right? Let's make it smaller. So -3 to +3 in the y. So if I press graph, okay, it got smaller than that. Oh, it's actually probably 1 then. Okay, so I'm going to go to -2 and 2. Okay, there we are. Okay, so here's the graph right there. So again, part A is to graph it out. So we're going to graph this out in part A. Graph T, right, Y. And then again, the graph of that is going to look something like the sideways kind of, there we are, the sideways parabola or semicircle up here. So something like this, okay? And then again, we have to do the direction. Did you pay attention to that direction, the way it was going, the way it was drawing? If you didn't, then go back to that y equals and press something and it'll reset that. So I'm going to just go to the t, retype the t right there, and it'll erase it, and then from the graphing, then it'll redraw it for me, okay? So pay attention to the direction. Here we go. There it is. Okay, so from here, I'm putting arrowheads. I'm going to start from here, going this direction, somewhere. If it's a small enough graph, I could probably just do 2, and I should be good. But if it's a bigger graph, then you probably need about 3 just in the middle, okay? Make sure it's obvious it's pointing a certain direction. So if it doesn't look obvious, redraw that thing right there, okay? All right, so it's going this direction around this way. So that was part B. Now, part C was asking us to prove, in this case, that is going the rightmost point. So in this case is special because when you're looking for the rightmost point, you're looking at this part right here, right? The point that is going furthest to this area right here on the right side right here. So let's think about this. We did first derivative for max and min, but how would you determine the right and the left? Okay, well, we could always change the equation. Remember when we do volume and we rotate it around the x-axis and the y-axis, we change the variables? Well, same thing with this one. With this right here, I did dy over dx. So if I'm going right to left, I probably want to go dx over dy instead. All right, so let's do that. So then if I put in the dx equation, dx is now sine t. So we're going to put in sine t all over cosine t, and then we can go ahead and do the derivative. So derivative of sine is cosine t, derivative of cosine is negative sine t, right? And we're going to set it equal to 0 to solve for it. So if I bring the sine over to the other side, 0 times anything is 0, so 0 is equal to cosine t. So then we're asking ourselves is when is cosine equal to 0? So remember, cosine owns the x-axis right here and negative cosine, right? So it can't be here, so most likely it would have to be here. But the limit is from 0 to pi, so from 0 to pi, so we're only going to take it up here at pi over 2 right there, okay? So at t equals pi over 2, it should be the rightmost part of the picture. All right, now that's going to be confusing because some of you guys can say it's 0 because it's on the x-axis right here, but it's not, right? So if I press in again, what do I press? Trace. So press trace, that will introduce the t, and I've put in pi over 2, pi, right, over 2, and press enter, it's going to go there, okay? So that's my proof that it is on the right-hand side of that, all right? So again, to do right hand and left hand, you want to make sure it's dx over dy. If it's the max or min, it's going to be dy over dx instead. All right? All right, so let's go ahead and try the homework now.